Hello, my name is Ishwar, and today my topic is about equalizer in communication receiver. In equalizer in communication receiver, there are different equalizers. The equalizers are number one, inter-symbol interference or ISI equalizer is used to reduce the error flow in most digital modulation techniques. The ISI arises when the digital transmission through the channel is derived, in which each received pulse is affected somewhat by adjacent pulses, due to which the interference occurs in transmitted signals. Equalization. These techniques fall into broad categories, which is first one is signal processing and antenna simulation. What is meant by equalization? The equalization is a process of removing the ISI and noise effects from the signal, and it located at the receiver end of the signal. The goal of equalization is to mitigate the effects of ISI, and however this goal must be balanced so that in process of removing ISI, the noise power in the received signal is not enhanced. A simple example: considered a signal S of t that is passed through a channel with frequency response at a receiver front end, and white Gaussian noise is added to the signal. So the input signal is receiver has a power spectral density NO. If the bandwidth of S of t is B, then the noise of signal power bandwidth is simple. Then the analog equalizer just multiplies the signal with some amount of noise. For the equalization, to mitigate the ISI introduced by the channel, it must estimate the channel impulses of the frequency response. Since the wireless channel varies over time, the equalizer must learn the frequency response of the channel and then update its estimation to the frequency response as the channel changes. The equalizers are of two types, which are linear type and non-linear type. In the linear type, there is traversal type and lattice type. In the non-linear type, there are another two types, which are DFE and MLSI. In the DFE, there is traversal and lattice. In MLSI, there is traversal channel estimator. Algorithms, there are different algorithms. In the equalizer types, the linear types, they are generally simplest to implement and understand conceptually. However, the linear equalization techniques typically suffer from the noise enhancement on frequency selective fading channels and are not used for more wireless application. Among non-equalization techniques, decision feedback is the most common, since it is fairly simple to implement and do not suffer from the noise enhancement. Symbol by symbol equalizer removes the ISI from each symbol and detect each symbol individually. The sequence estimator equalizers detect the sequence of the symbol, so the effect of ISI is a part of estimation process. Then there is folded spectrum and ISI free transmission. In the folded sector, the train is the impulse of responses and are used by matched filters. If we sample y of t, then we'll get the desired ISI, and we can just sample the baseband noise. Then the linear equalizers are used to minimize the error between the received symbol and the transmitted symbol without enhancing the noise. Although the linear equalizer performs better, but its performance is not enough for the channels to serve ISI. Zero forcing ZF equalizers. The ZF equalizers are used for combined systems. Then it is minimum mean square error MMSI equalizer. It is used to minimize the average mean square error between the transmitted power and the received power. That is, we find the minimum EK value by using matched filter which is HEQ value. First of all the ideal infinite length MMSI equalizer cancel out noise and whitening noise. Second, the infinite length equalizer is identical to ZF filter except noise term NO is so that the absence of the noise, the two equalizers are equivalent. Finally, this ideal equalizer design clearly shows a balance between inverting channel and noise enhancement. The maximum likelihood sequence estimation avoids the problem of noise enhancement since it does not use an equalizing filter. Instead, it estimates the sequence of transmitted symbols using a Gram-Stimp abnormalization procedure. DFE model or decision feedback estimate or equalization is the feed forward filter with a received sequence as the input followed by a feedback filter with a previous detected sequence as the input. The DFE determines the ISI contribution from the detected symbols by passing them through the filter. The resulting ISI is then subtracted from the incoming signal. Since the feedback is figure below sits in the feedback loop, it must be strictly causal or else the system is unstable. The feedback filter of the DFE does not suffer from the noise enhancement because it estimates the channel frequency response rather than its inverse. The equalization training and tracking are used for the equalization training. The equalizer has to be trained before deploying, hence the bit decision output from the equalizers are typically passed through a threshold detector to round off the decision of the nearest bit. The resulting round off error can be used to adjust the equalizer coefficient during the data transmissions. This is called equalization tracking. The tracking is based on the premise that if the round off error is non-zero, then the equalizer is perfectly trained and the round off error can be used to adjust the channel estimation inherent of the equalizers. Now let us recap what we have learned. There are different types of equalizations, that are linear equalizations and non-linear equalizations. In linear equalizations are easy to construct, and non-linear equalizations are small complex. Here in the MLSI and DFE, in the linear equalizations we are going to use adaptive filters and in non-equalizers we are going to use the feedback decision frequency or DFE. We are going to use the forward filters, and the decision can be used to take the and equalization training and tracking. We are going to use a round of threshold frequency to track the decision. Thank you.